Hey guys, how's it going? In this video we're going to be taking a look at the merge node for both Nuke and Natron. The merge node is such an important node, it's basically the backbone of any sort of compositing operation. It's what combines two images together, so it justifies having its own video. We're going to be taking a deeper than normal look at all of the knobs in the node and some of the merge operations that are there, the most common ones, paying particular attention to the over operation, which is the standard merge operation that any sort of compositing software or video editing software does when you put two layers over the top of one another. So let's get into it. So here in Natron we have our two images, the background image and the foreground image. We're going to merge these like we did before with a merge. We're going to plug the B into the background, B for background, easy to remember, and A into the over. A for over, it almost sounds similar, but anyway, B for background, A is the one you have left. So with that, it's A over B, and we get this image. Beautiful, nice and easy. So in the merge node, we have these knobs here, and the primary knob is the operation. This is also called blend mode in softwares like Premiere and After Effects, and I think Photoshop as well. So consider this and operation and blend mode to be the same thing, and there are options, and some of these overlap. I think in Premiere and After Effects, the over operation is called normal. Same thing, different name. And some of these are available in those softwares as well. Over being the most common one, and we're going to take a look at a couple other popular ones in just a moment. Before I explain any others or any knobs, I'm going to go into too much depth on the mathematical equation behind the over operation. Let me make it clear. What I'm about to explain, you don't actually need to know. You just need to know that A goes over B for the merge operation. That's it. But what I'm about to explain is the exact math that happens under the hood of the merge operation. So it's good to know, but you don't have to. I'm going to put a blue dot up in the corner here, and while that blue dot is here, if you don't understand anything I'm saying, don't worry. When it goes away, start paying attention again. To explain the math behind the merge operation, I can use the expression node, but unfortunately I don't actually know the expression language that Natron uses. There is documentation online, but I already know how to use the expression node in Nuke, so I'm just going to jump over to Nuke and explain it there. Okay, so we're in Nuke right now, and I'm just going to create Nuke's version of the merge expression node so that, see, it looks a little different than the Natron one. And what I'm going to do is write out the merge equation in here. So to get the merge equation, I'm going to do the tooltip thing. So I'm going to hover over here, and we can see that over is A plus B, and then parentheses 1 minus A. So in Nuke, what it means with a capital A, it's referring to the pipe, the A and B pipe, and when it's a lowercase a, it's referring to the alpha channel from that pipe. It also doesn't work perfectly if I just write out that equation exactly as it is. It's a little frustrating that I don't write it out that way, but no matter, we're going to write it out in a longer form that makes much more sense anyway. So if I delete this right now and I just come over to this setup right here where I just have the B pipe of the merge expression plugged into the checkerboard and the A pipe plugged into the color wheel, and so at the moment there's nothing in here, and if I look at it, all we get is a pass through of the B pipe. So remember that the merge node is essentially A plus B, and then with some extra bit including the alpha channel. So we're actually going to start with the alpha channel piece because that's more relevant. So what we actually have to do is subtract the alpha channel. In this case it's the circle around these pixels here. We need to subtract this from this. But if we look here, the pixel value is 0.5, 0.1, so it's actually quite a low pixel value, and the alpha channel of this is 1. So if we minus 1 from 0.1, we're going to get negative 0.9, and we can't have negative values, it will ruin the merge operation. So we actually have to use a bit of multiplication to get a relative minus, which is why the equation is written that weird way in the merge node. So what we're going to do it one channel at a time. So we're going to do the red channel, green and blue separate. Starting with the red, we are going to do 1 minus A. And in this node, to tell it which alpha channel to include, we got to put a capital in there. So it's 1 minus the alpha channel from the A pipe. And if we just hit enter and we view this now, we can see a pretty arbitrary result. It's essentially in the red channel, so if I look at just the red channel here, we get 1, which is this value here. So if I take away this, we just get a value of 1 in the red channel, okay? And then minus the A pipe's alpha channel, the alpha channel being 1 over here. And we look at that, so we get, sorry, in the red channel, so we get 1, which is this value set here, minus the alpha channel. So we just get this circle in the middle, and we get no negative values in the red channel, so just 1 and 0. So far, so good. So the next step is we need to get the red channel from the B pipe ready to be plussed with the red channel from the A pipe. So if we look at this merge node for it to see what we're trying to get, this is the red channel from this normal merge operation. So you can see here that we actually have nothing in this range here, because there's a solid alpha and there's no red values. So if we're looking here at the RGBA and we look at the red channel, there's actually no values around this section of green and blue. So the red starts over here and fades off in these areas. And so when we merge that in the red channel, we want to see actually nothing there. So if we just make this merge operation a plus, so A plus B, no alpha interference whatsoever, we get that. Okay, so we need to prep the B pipe, this checkerboard image, by minusing the alpha channel from it, a relative value of the alpha channel. So we'll put that back into an over. So we're looking at the red channel of our expression, and so we've got our 1 minus A, and now we need to multiply that by the B red channel. And because of the mathematical ordering, I'm just going to make this very straightforward by putting parentheses around this part of the equation so that it does the 1 minus A first and then the multiplying by the red channel. So if we look at that, so now we have the color pixels minus the alpha channel from the A pipe, but not at any point going into negative values. So if I'm just hovering the mouse over here, looking at the red channel, we can see pixel values that will be unchanged from the original. And in here where the alpha channel is 1, it's done a minus. So now moving on to getting the red channel from the A pipe over the B pipe. So it's just a plus from here on. We've prepped the background red channel, and now we just need to plus the foreground red channel over the top. So to do that, we just add plus A red, and just to be super sure that our equation is working in the correct order, I'll add more parentheses around the first part, just like that. So what that does is 1 minus A, and then that result multiplied by the red channel from the B pipe, and then the result of that plus the red channel from the A pipe. And now if I'm looking at the red channel right now of the merge expression, and if I compare that with a normal over operation, we can see we get the exact same result. And we don't get the same result just yet looking here versus here, because we're only doing it to the red channel. So if I take this equation, I copy it, and I paste it in here, so this is now going to be the green channel because this is ticked here, so red tick, green tick, blue tick. And if I just change the R's to G's, red to greens, we get it working in the green channel as well. Do the same for the blue channel with B for blue, and done. And so now we have the same result as the merge node. And there is one more thing to pay attention to, which I won't go into great depths about, is the alpha channel has its own separate equation, which I have here in this node. So if I just copy and paste that, we're not discussing the alpha channel right now. But now if I look at the alpha channel as well, it also works. This may not be completely correct math. I think there's also an if-else statement that needs to go in here to make sure it handles values above 1 and below 0 correctly. But for anything between the range of 0 to 1, this mathematical equation works the same as the normal merges alpha mathematical equation. And as you can see, they are different. So I can just quickly prove that I've done the math correctly by having a merge expression and a merge at the same equations over here, and I'm just doing a difference. This will tell me anything that's different between this and this will show up here, and just to check that I'm not doing, don't have any very subtle differences, I've just multiplied the result by 10,000, and you can clearly see there is no difference between this merge expression and this merge node. Okay, so that is how the merge node works in both Nuke and Natron. But as I say, you don't really have to understand that exactly, but it is good to know. Jumping back into the more normal set of features. Okay, jumping back into Natron now, we're going to go over a couple of the other common merge operations. So with merge being the most popular one, let's go over some more. So under is the exact same as merge, except with the inputs swapped. So if I swap these around, we get the same result as we had with the over, which makes sense. Over, under sound like the opposite. There's also plus, which is exactly what it sounds like. It just says A plus B equals the result. And it doesn't matter which order these are in, because, well, it doesn't matter which order you plus A and B together, they equal the same result. Same deal with multiply. It's exactly what it sounds like. Doesn't matter what order the inputs are in, it's just A multiplied by B on a pixel per pixel basis. These are all on a pixel per pixel basis, just to clarify. We also have minus, same deal. Which order are these in? I can just hover the mouse over to confirm that it's A minus B, and then we have from, which will be the opposite of that, which is B minus A. And so those are all very straightforward. We also have a couple of others that are very common, that being stencil. Stencil basically does the first part of the merge operation where it removes the alpha channel from the B pipe, just like that. So it's basically, it is a stencil, you know how a stencil cuts something out, that's what it's doing. And it doesn't go into negative values. So as I said, it's the first part of the merge equation we just looked at. So it constrains the lowest values to 0 when the alpha channel is at 1. So stencil is a merge operation I use all the time, especially when dealing with mats and green screens. We also have screen, which is kind of like the invert of stencil, especially when dealing with mats. I'm looking at this. This is my, so dealing with mats, this is my alpha channel from the background, and this is my alpha channel from the over. Screen just adds them together, but without going over a value of 1. So it's a good way of keeping your mats in a reasonable range, but also combining them in a nice way. We've got difference, which we just used before. It's more good for debugging or some sort of difference keys you can get. It can be quite handy to use. I use it primarily just to see specifically what the difference is between two images, especially similar looking images. Or different grade nodes. You can use it to see if you're trying to match the grade to something, an identical image with a different grade. You can use the difference to try and get the pixel values as close to 0 as possible. Average is a good one, does exactly what it sounds like. A plus B divided by 2. Some people use in, I use mask. They work very similarly. It just says whatever's inside the mat from the A pipe, keep it. And as you can see, there's the pixel values from the background revealed through the alpha channel. I think max is a good one to know as well. It just takes the highest value between the inputs and reveals them. So in this case, there's no values out here, so it's just these. And a couple of the highlights on the X-Wing are brighter than the plate behind, so it's going to keep those. But some of the values on the X-Wing are darker than the plate behind, so it's going to remove those. And I think those are probably the most common merge operations that I use. But if you're ever needing a merge operation, you don't know which one it is, you can just, if you hit the top version and put your mouse over the knob, you can toggle through with the arrow keys, and you can just flick through until you get a result that you are happy with. So we go, oh yeah, well that looks pretty good. Oh, it's the over. Okay, cool, so I'll use an over. Okay, and to round this video out, I'm going to look at the rest of the knobs that are in this node and what they do. So we've looked at the operation in great depth. Now the bounding box. Bounding box is actually very important. I should probably do a video on it separately, but we'll go into it now very quickly. So every image has a bounding box, and in this case it's this dotted line around the image. In a full screen image, this line lines up with the resolution, so you can't always see it. But with images, especially CG rendered ones, you can see the bounding box, and it's basically just a way for the image file to say only look for pixels in this range, and that dramatically speeds up the computation time of softwares like Natron. If it says, well, I don't have to worry about pixels out here and all of this space, just here. And so when you do a merge operation, you also combine the bounding box. So in this case, we get the bigger bounding box, which is the background plate. And so that's union, or it could be B, because B, the bounding box from the B pipe encompasses the entirety of the bounding box from the A pipe. Bounding box is a very important principle, and when working with After Effects and coming into node-based, well, it's not necessarily a node-based feature, but a Nuke Natron sort of feature. It's a common feature, but it's not represented in After Effects, at least not that I know of. So I had to wrap my head around how the bounding box worked, and it's frightfully straightforward. It's just almost hard to get your head around how straightforward it is. So if I was to look here and I just want to move this bounding box outside of the resolution so that we can clearly see what's happening. So now it's the bounding box is outside the resolution, and so if I go A over B, you can see it's combined the two bounding boxes together in always a rectangular shape. So now I can change the bounding box operation. So if I go B, it's just going to cut this off right here. And when it's at union, these pixels on this X-wing actually exist. So if I put another transform here and move this over, put a couple of zeros in there so we can see, you can see the pixels are actually still there because they're inside the bounding box. Whereas in the merge node, if I put the bounding box to B, it's going to cut the bounding box here, and it's going to stop looking for pixel values outside of the bounding box, just cutting off the TIE fighter here. So it can be very useful if you know you're never going to see this corner of this part of the image once it's gone out of frame. Clip it with the bounding box and you'll speed up the script, which is a very tidy way to work when you get into professional workflows. So it's important to understand. And actually I'll leave that here so we can see the rest of the operation. So that's the B pipe is just taking the bounding box from the B. Union is combining the two of them. A is exactly what it sounds like. It's taking the bounding box from the A and as opposed to the B, and we get that result here. And intersection takes the smallest chunk. Intersection can be useful for mask operations where you want to take only what's inside a particular shape, and so you don't need to do union B or A, you just want the smallest possible bounding box. Yeah, they're all important to know and commonly used. And so we're going to go back to union and just put this back in the right place. This alpha masking thing, I have to confess, I don't actually know what it does, but it is only available with some merge operations, and when I use it, I don't see a difference. So yeah, I've never used it. I don't know what it does. I don't think it's in Nuke. Could be wrong, but anyway, this next section is seldom used. I've only used it a handful of times in my entire career, but it can be useful to be aware of, especially if you open someone else's script and they've used it. So the A channels and B channels are basically which channels are being used from the inputs, and I'll get to the output in just a second. So if we wanted to not use the green channel from the A pipe, it just won't merge that. But bear in mind that because it's doing the alpha channel calculation, it is stenciling the alpha channel from the green channel. So if I look at the green channel, it's not merged, but it is stenciled. So if I turn the alpha off as well, now the B pipe, the green channel is just the B pipe. So we've skipped any sort of processing on the green channel whatsoever, but the red channel and the blue channel still have processing, but they don't have the preparation done by the alpha channel. So if I turn this back on, it should look like that in the blue channel, but because I've turned it off, it's just doing a regular plus because we've skipped that alpha part. Same thing with the B channels. We can just not merge the green from the B channel. So if we look at the green channel, all we're getting is the green from the A input. The output line is sort of misleading. What it's doing is it's saying output the B pipe plus merge it with the selected channels. So if I turn all of these off, we don't actually get nothing, which is what I would have expected. We get just the B pipe. So I'm looking at the merge node right now, and it's just giving us what's coming from the A. So if I turn on the red, now we're getting the red merge. So if I look at the red channel, it's working fine. It's doing the alpha preparation up here, and then it's outputting the B pipe plus the merge from the red. So we are getting that alpha stencil, so it actually looks right. If we didn't, we would be getting it looking like this. And so we can turn on the green as well, and then turn on the blue, and we get everything, and well, except for the alpha, now we get the alpha as well. So if I was looking at the alpha there. The next section is the channels. If you have more channels in your merge node, more channels will show up here, but as for now, we're only working with RGBA, so we're just getting none and RGBA showing up. Same with all of these. See how we could have all of these layers showing up here if we had them coming in the A and B pipe, but we don't. All planes will remove that section, and it basically says for each of these, do it to every channel that is listed here. All doesn't make a difference at the moment because we are already doing it with all of the channels we have available to us. So mask is another input over here. So if I just give something for the mask input, like a color wheel, it's using the alpha channel by default. So if I plug the mask input to the color wheel and I look at this now, you can see only what's inside the alpha channel is being merged. That's because mask is ticked on. If I turn this off, even though it's plugged in, nothing is going to happen. And I think it's off by default. So if you ever find that the mask input isn't working, oh look, it actually turns it on by when you plug it in. That's good to know. Boom, turns it on automatically. Okay, that's cool. And you can select what channel, by default alpha. We can change it to the red. Oh, make it see so we can see a little more. Let's make it the green. You can see the green channel looks like this, whereas the alpha channel looks like this. So it's doing like a gradient fall off in that direction. We can invert it. See that clearly. We can use the red channel. So it kind of fades it back on. Anyway. And last but not least, there is the mix. And the mix is essentially a gradient on and off button. So 1 being completely on, 0 being completely off. If I turn this all the way down, it goes off, 1 on, 0.5, halfway on. And so this is kind of like a disable option, except it's animatable and it's got a gradation, so you can kind of fade things on and off. The mix is a very useful tool that is in most nodes. If you look at the blur node, the grade node, it's in a lot of the nodes, so it's a good knob to be aware of. So that finally does it for the merge node. As you saw, the merge node in Natron and Nuke are basically the same, so what I've just explained here applies to both. It's a very important node, so it's definitely worth understanding fully, but what it really comes down to is just understanding the operation, a couple of the common merge operation options, the bounding box, which is very simple, and the mix and the mask as well. They're the most common features of the node. So I hope you found this beneficial. In the next video, we're going to be looking at marker removal and basic paint techniques. So yeah, stick around for that. Thank you very much for watching, and I'll see you in the next one.